Welcome to part 3 of the shop art project. As you can see, I've got the LED wired in, hot glued in, and we've got the wires going down. What I did here is I reinstalled the original binding post back into where the pilot light was going to go. And we're using these as tie points now. So we've got the 3 volts coming out, these leads here. It's going to be feeding the LED. We're going to monitor the voltage on the LED. I tried putting in 1.7 volts on the LED. I boosted it up to 1.8. The LED would not light until it hit 2 volts. So we are going to be monitoring the voltage going into the LED by way of a series resistor. So these are going to become tie points here. The resistor will be put across here. This will be the black, this will be the common, and the black from the LED, which I just installed. I got a red and a black wire. So the red wire will come down to one of these terminals here, probably this one. The red feed from the output of the DC to DC converter that Jim made will go here, and then it'll be 3 volts from here to here, because this is where the negative is going to be. This is the tie point for the negative. And there'll be a resistor here, so we got 3.3 or 3.2 volts here in reference to the ground, okay? And here we should have 2 volts. And we'll do that all by substitution. Like I say, we don't use math. Okay, so that's what I did. And to look at the front of this, I think it looks good. I drilled a 5/16 hole. It fit perfectly in there. So it looks better with a pilot light up on the top because it's so bare on the top. And down at the bottom, we got the original binding post in where the push button is that I put there. There was no binding post, as I said. That's the way I got it. So that's going to be the power for the display. And the whole thing will be controlled with this on and off switch right here, which will turn on the DC to DC converter and also turn on the light. So that way we know it's on or off. So I already established that it lights very bright at 2 volts. That's what it calls for, so we're not going to push our luck and go over that. There will be maybe a variation. I don't know. The LM317, is that a regulator? I guess it is. You guys know more about it than I do. I think it is. But it's going to vary with this wall wart here anyways, which puts out 7 volts, even though it says it puts out 4.5. It puts out 7 volts. But that varies with the line voltage. It could be a little under 7, or it could be as much as 7.5. So there'll be a variable there, but I think with a resistor in series with the LED current limited, and you don't need a high wattage, probably even a 1/4 watt would be fine. I've got 1/2 watts, and I'm sure I can come up with a resistor that'll go from here to here. So I'm going to be doing the wiring off camera, just like I did when I drilled this and everything else. Got a day, it's getting mild out there now. It's about 55 according to the weather report this morning at 11 o'clock. I'll be back. Don't go away. Okay, we did some more hot gluing here. It's not quite dry yet. Ran the wires down, ran the red over here, red and the black over here. We got the black tied down, but it's not finished yet. We got a clip leaded in here because we're going to experiment with the resistor. This is the common. So we got the negative of the output, which is 3.2 volts from the DC to DC converter here. Negatives here. So the common negative here is also the common negative for the LED, and I marked it because the LED is not marked. And nowhere on the specs does it show any markings. So we had to experiment. So what we're going to do now is we're going to put a voltmeter across these terminals, which I bent over so I can solder easily. I had to do it after I got it through the hole. It's hot glued in, which is the easiest way. There is no clip or anything that came with these lights. So I don't know of any way you're supposed to hold them in. They used to have, years ago, those metal push clips that you can push on, but they're virtually impossible to get off. I don't have those. I might have had them years ago, but that stuff's gone long ago. Anyways, we're going to monitor it and make sure we get 2 volts on the LED and not exceed that. The 3 volts, 3.2 coming out of here is going to be dropped with a resistor. So now, this here, a red wire, goes directly underneath here into the LED. And the red output here, which I'll shorten the lead, is going to go here. So the potential between here and here is 3.2 volts. And the potential from here to here, which is going to be the same as this, is going to be 2 volts. Or at least wise, that's my method of madness. So what we're going to do now is shorten this and put this over here. So between here and here we got 3.2 volts, and we got the drop-in resistor going from here to here for the LED. This is the LED red wire, as I said before. So let's get going on that. I got to do some experimentation with the resistors in my box. I will not do that on video. Like I say, I don't do math, I don't do formulas, I can't do them, and there's no use getting aggravated with it. So we do everything by experimentation. Alright, we'll be back, don't go away. Alright, you'll have to take my word for it. I can't show you the meter and do that. It's impossible for me to do that. Alright, so I'll explain. I got a 1,000 ohm resistor here. I start off with that. I could use the substitution box, but it's just as easy for me to grab a resistor out of my bins here. I'm starting out with a 1,000 ohm resistor. I got no DC voltage across the LED. We are going to turn on. Well, we don't really need to turn on the thing, but we do have it on. We don't have to really turn this on. Well, I did, because we're getting a 3.2 volts out of here at all times, as long as the main power switch, which is right here, and I'm off camera again, as always. I can't get you in camera and get a close-up too. I can't do that. So, this is the output of the DC to DC converter. In other words, this is the 3.2 volts right now. So we're putting the resistor from there, and this wire here that's on the binding post, which is not yet soldered, goes to the LED. So we'll hold it on here. I'm getting 2.6 volts. So 1,000 ohms is too high. 1,000 ohms is too high. Let's just look and see if the LED is probably going to burn that damn thing out here. Nope, the LED's not even lighting. Something. I turned it off. I got 3.2 volts coming out of the DC to DC converter. I don't have a 470. I do in my loose resistors, but it would take me half the day to find it. So let's try a 220. All right. So let's see what the reading is here. You'll have to take my word for it. I can't show you the meter. I can, but I'm going to have to move the camera. 1.9 volts. LED is just barely lit. So this LED needs 2 volts. It's not happy with anything under 2 volts. Now I'm turning on the display. LED is just barely lit. 1.948. Let's turn the display off. 1.958. Okay, 220 ohms. So, as I said, experimentation, off camera again, of course. Let's go to, let's see what else I got up there. Well, I have to drop down to 100 ohms because I don't have anything in between. I'd have to, like I say, I'd spend half the day looking through my junk box. So let's try 100 ohms. 2.05 volts across the LED. I think we can live with that. 100 ohms. And the LED is lighting pretty good. So that's what we're going to use. All right, I unplugged the heater. It's getting comfortable in here now. I got too many wires hanging in the way and I almost knocked my camera over. So we're going to solder that in there. All right, we're going to do one end at a time here. Let's see if that's pinched or not. I'm trying to hold 10 things at once here. Fortunately, these terminals that are on the binding posts have an open hole here. If I can get that to stay up there. That's my problem, trying to hold things in place while I'm soldering. And they don't stay in place, and then when I get the iron on it, it moves. I think we're in there. Okay. Trying to get two things soldered at once is not easy. The wire's moving all over the place. The resistor's in place, but the damn... I can't see to pinch that wire because I need the magnifier. Like I say, I don't use my head visor. I'm going to have to just tack it in. There's nothing I can do about it. I'll have to tack it in. Fill the soldering iron and bring it over. See, I use a lot of heat and I hold the iron on and I cook up parts that way. See, I got the resistor soldered. No, I don't either. There's no solder in anything. Just put more solder in there. This is why... Damn it. This is why I can't solder to things, because, you know, they get very hot and you're holding things in place. And I use long leads so it don't cook up the part. And no, you're not supposed to blow on it, but I need to make sure it's cooled down. Good. It's sloppy, but it's on there. Okay, so we got that on. Now, I'm going to put a hook in this. try to get that down. In the hole. And bring that up in a horseshoe. There. Now, can we get the wire in there? We got room for the wire. That's the question of the day. We got to move these other wires out of the way because I'm going to be burning them up. All right, now, this is the positive of the output of the DC to DC converter, and we got to shorten that a little bit. And we got to strip it. And we'll tin it. It's stranded wire, but we got to tin it. It's thin, unfortunately. I have some 18 gauge Belden, but there's only a little bit on the roll, and I really don't want to use that. It's 18 gauge. It'll work perfectly on this, but it's red, but it's all I've got. That stuff's expensive, so I got it at a Jewett City flea market. It was $1 a roll, but that particular roll was not full. So I don't want to use that. So I'm using wire that I have on hand. Now, here it goes. If I didn't tin this, the strands would go all over the place. Can't tell if it's in there or not. It's in the hole, but all right. Now, let's get the iron tinned again. Sorry about my ugly head, but I need to get my face in there. You see, that's why I leave the resistor leads long. I do that when I have to solder. You can't go short because I can't see. I gotta leave the iron. Sometimes the solder don't take. Sometimes the point of the iron is not even on the work. It's below the work or whatever. All right. Okay, I can trim that. Let me put the iron off for now. We don't always turn your soldering station off when you're not using it, even though you got to wait for it to heat up again, or the tip will get tarnished. Okay. Now, before I dress these leads and hot glue them if need be, some of them are a little loose, but I could go around controls and dress them in there. Now we know a 100 ohm resistor is going to be good. And it's sticking up, but no higher than this. All right, so now we'll put the iron back on. We're going to connect our leads now properly. We got to get a little bit more stripped here. We got to tin that. I tin the stranded wire because when I push it through the hole, a lot of times strands flare out like that because, again, I can't see what I'm doing. So if I tin the whole thing, it'll go in as one piece. And it makes a better connection too. So we're going to tin it before we even try to put it in place. So it's going to be a little long. I'm not going to worry about it. Not going to worry about it being a little long. When I do wiring, I always have it long because sometimes when I strip a wire and I don't get it into the groove properly, I'll cut it right off. So if I have it a little long, I screw up, I can continue. There's a method to my madness. Sometimes it seems like I'm a little mad, but you have to do what you gotta do. You know, your man's got to know his limitations. Come on, I can't find a hole. Here it is. Them glasses don't give me enough magnification, but I've tried everything under the sun. The ones that do give me the magnification, I'm banging into my work because I gotta have my face like this. You know, I can't work a foot away from my work. I can't see what I'm doing. So I'm not the ordinary blind tinkerer that can use ordinary vision aids. Is that taken? I really don't know. I think so. Now, before we try it out, we're going to do well, actually, I can be assured that there's no shorts. I already took an ohm meter before I did any of this, after I put the binding post back on, and make sure I wasn't getting any continuity between the binding post and the chassis, and I wasn't on any of these. So, it should be okay. These wires aren't bad. They're not bad at all. All right. .05 volts. And the display's not on. This is a pilot light that tells me that the unit is getting power. And of course, starting that button down there starts this. Okay. So we're going to hot glue this. We got to plug the hot glue gun back in. We're going to, well, maybe I'll try to dress this up. Maybe I won't have to hot glue it. But there's the voltage on the LED. So the LED is getting its proper voltage. I'm using a 100 ohm resistor. .2 volts coming out of here. That supplies this. And is supplying the LED through a 100 ohm resistor. So that worked out really well. All right. Let's put this thing back together. I think we're done. All right, there it is. All done. And we got enough wire here. We can always tie it up here, not a problem. That's what I wanted. I wanted it to come out. There's about probably a 1/4 inch between the back of this frame and that. And it works good. And when you turn this off, it's off now, even though you can still see it. This light shows, and I wanted it that way, so when I turn this power switch off, the whole thing goes off, see? And then when I want to start it, I just push this, and it's on. And I can turn the whole thing off. That's it. Thanks for watching.